Hi, my name is Matt. I'm doing a live solve of this year's 2019 AMC 12A. Haven't looked at the problems before. I'm a little too old to take the contest myself, but the point of this is just to kind of work through the problems out loud so that you can hear my problem solving process and kind of get an idea how you might think through these problems. So hopefully this is helpful to you. I'm going to do something a little unusual. I'm going to start with problem 21 through 25 and just look at those last 5 problems. I don't know if I'm going to solve them immediately, but I want to take a look at them and get the problems kind of rolling around in my head as I would do the earlier ones. Okay, so let's begin. Okay, 21 says, let z equal 1 plus I over root 2. What is this whole expression? Okay. So I think we're going to want to put z in polar form. So I can tell z is equal to e to the I pi over 4. Okay. So I know that powers of z are they're one of 8 things. And I want to know how many of each one there are. Okay, so mod 8 is going to be important, and I need to know the squares mod 8. So let's do that. 1 squared is 1 mod 8, 2 squared is 4 mod 8, 3 squared is 1 mod 8, 4 squared is 0 mod 8. I should do 0 squared is 0 mod 8. 5 squared is same as 3 squared, 6 squared, same as 2 squared, 7 squared, same as 1 squared. Okay, that's enough for 21. 22 circles, both centered at O, have radii 20 and 17 respectively. So I'm looking at concentric circles. The bigger one is omega, this is gamma. Equilateral triangle ABC whose interior lies in the interior of omega, but in the exterior of gamma, so it's like in here, has vertex A on omega. The line containing side BC is tangent to gamma. So I think it looks maybe something like this. This is BC. AO and BC intersect at P. So I think I want to move these. Should look like this. BCP. BP over CP equals 3. And I want to find the side length. Okay. Good to at least have the picture. 23, define these binary operations by diamond is a to the log base 7 of b, heart is a heart b equals a to the 1 over log base 7 of b. And then we have this recursive sequence. Okay. This is weird. Okay, they start with a sub 3. It's kind of strange to me. All right, so a sub 3 is 3 heart 2. Which is 3 to the 1 over log base 7 of b. Or 2. I'm just kind of thrown off by these operations. Okay, but I think doing a few will give me a sense. Now a sub 4 is equal to 4 heart 3 diamond a sub 3. Okay, so this is 4 to the 1 over log base 7 of 3. And then the diamond is raised to the log base 7 of 3 to the 1 over log base 7 of 2. Okay, so this equals 4 to the 1 over log base 7 of 3 times log base 7 of 3 times 1 over log base 7 of 2. Okay, so my hunch is this pattern continues and this number just goes up. So that's good for now. 24, for how many integers n between 1 and 50 inclusive is n squared minus 1 factorial over n factorial to the n an integer? Okay. Interesting. Let's try small examples. So n equals 1, we get 0 factorial. Let me organize this a little better. 0 factorial over 1. Yes, that works. N equals 2, we get 3 factorial over 2 factorial squared. That's not good. N equals 3, we get 8 factorial over 3 factorial cubed. Okay. Do we have enough 2's on both sides? Yes. Do we have enough 3's on both sides? There's 3 3's on the bottom. On the top there's 2 3's. So this is not good. Okay, I'm kind of getting an idea and we're going to want to break it down by primes. Let me look at 25. So 25 says, let this be a triangle whose angle measures are exactly these things. Then define a sub n to be the foot of the altitude. Okay. So I'm going to draw this a little not to scale. A is the smallest angle. So that. I think the way I drew this, that should be A, B, C. Okay, A sub n is the foot of the altitude from, so that's A sub 1. B sub n is the foot of the altitude from B0, I see. So this is B sub 1. C sub n is the foot at this altitude. And when does it become obtuse? Okay, so we just need to relate these angles to the whole angles. All right, well, I want to do number, start from the beginning. That's good to give me a sense of those problems. All right, number 1. The area of a pizza with radius 4 inches is n% larger than the area of a pizza with radius 3 inches. Okay, so ratio of areas should be the square of the ratio of the radii. So this is 16 over 9, which is 1 plus 7/9. Okay, so I want this 7/9 as a percent, which is 77.7, so E. All right, 2. Suppose A is 150% of B. So A is 3/2 B. What percent of A is 3B? So that means 2A is equal to 3B. So 3B is 2 times A, which is 200%. D. 3. A box contains 28 red balls, 20 green balls, 19 yellow, 13 blue, 11 white, 9 black. What is the minimum number of balls that must be drawn from the box without replacement to guarantee that at least 15 balls of a single color will be drawn? Okay, what's the most we can get without 15 balls of a single color? We can draw 14 red, 14 green, 14 yellow. We can only get 13 blue, 11 white, 9 black. I have those numbers right? I think so. And then I should add 1 because I need to draw an extra ball to get 15. Okay, so this comes out to 33, and this comes out to 42. So together these are 75, so 76. Number 4. What is the greatest number of consecutive integers whose sum is 45? Okay. If there's an odd number of integers, then the average times the number is equal to 45. What's the greatest number of integers we can get? N can be 45 and A can be 1. Okay, if there's an even number of integers, then we have the average is something like 2A plus 1 over 2, and times the number is 45. So we have 2A plus 1 times n is 90, which means we can take n to be 90, A to be 0, and yeah, that should be good. So D is right. 5. 2 lines with slopes 1/2 and 2 intersect at 2, 2. All right, I'd like to draw this. Here's 2, 2. Here's slope 2. Here's slope 1/2. Okay, and the line we're talking about is x plus y equals 10, so that's like over here somewhere. All right, now how are we going to get the area of this triangle? Well, let's at least get the coordinates. So y is 2x minus 2. That's this line. And x plus y equals 10. So 10 minus x is 2x minus 2. So 3x is equal to 12. So we get 4, 6. Okay, and this point is 6, 4. I kind of wish I knew shoelace formula, but I don't. So let us do it differently. All right, so I'm going to move this along the line with slope 2. So if I move it down, I get 5, 2. This triangle has the same area, and the base is 3, and the height is 4, so the area is 6. Number 6. The figure below shows a line L with a regular infinite recurring pattern of squares and line segments. How many of the following 4 kinds of rigid motion transformations of the plane into which this figure is drawn will transform this figure into itself? Okay, so let's just go through them one by one. A rotation around a point of line L. Yeah, I can rotate around this point 180 degrees. So this is yes. Some translation in the direction parallel to line L. That's this way. Yeah, sure, I can do that. The reflection across line L. No, that's definitely not. Some reflection across a line perpendicular to line L. No, because any line is going to send these lines to go the wrong direction. So this is no, and I think the answer is C. All right, 7. Melanie computes the mean, median, and modes of 365 values that are the dates in the months of 2019. Okay. The days of the months. 12 ones, 12 twos, all the way to 731s. Let D be the median of the modes. Which of the following statements is true? Okay. What are the modes? They're the 12s, so 1 through 28. So D is the median of the modes, so that's 14.5. Okay. The mean is bigger than D because it's sort of weighted up by the bigger things. The median is also bigger than D. I think. Okay, what's the median? Okay, it's taking longer than I would like to, but that's okay. So the median, there's 365 values, so I want the 183rd of these. If I do 12 into 183, I get 63, 5, 60, the remainder 3. So that means I get through all of the 15s, so the median is 16. Okay. What's the mean? Even if there were equal numbers of all of these, it would be 16, so it's less than 16. So I get d is less than mu is less than m. Okay, 8. For a set of 4 distinct lines in a plane, there are exactly n distinct points that lie on 2 or more of the lines. Okay. What are all the possibilities here? So, 4 choose 2 is 6. So if I might get 6 intersection points, that's one possibility. Okay, now what if 3 go through a point? Which must happen if I don't have that picture. Oh. This is the most I can get, okay. So here I can have 3. Oh, sorry, that's 4. So if 3 go through a point, I can either get 4, I can get 3, if 2 are parallel. I can get 1 if all go through that point. So now I can assume no 3 go through a point. Okay, if 2 are parallel, I could have all of them be parallel, so I could have 0. If 3 are parallel, I just get 3 again. If 2 are parallel, then I can have that. That gives me 2. And then the other one, go like that. I get 3. Go like that, I get 4. Go like that. And I get 5. Okay, 6, 5, 4, 3. Can I get just 2? So if I get 2, then two have to look like that. But then to get the second one, where's it going to be? If it's here, then I'm going to have to intersect and go like that. I don't think I can get 2. Okay, so this is 11 plus 7 is 18, plus 1 is 19. I think it's D. Okay, that's tricky. I'm even still a little concerned about that. Okay, let's do number 9. A sequence is defined recursively by a1 is 1, a2 is 3/7, and a sub n is this. What's a sub 2019? All right, let's calculate. So a sub 3 is equal to 1 times 3/7 over 2 times 1 minus 3/7, which is 3/7 over 2 minus 3/7 is 14 minus 3, 11/7. Okay, so I get 3/11. Okay, I noticed the denominator went up by 4. So a sub 4 is equal to let me just try to verify this pattern in general. So let's say 3 over a times 3 over a plus 4 over 2 times 3 over a minus 3 over a plus 4 is equal to 9 over 6a plus 4 minus 3a, which is 3 over 2a plus 8 minus a plus 8. So the pattern is right. Okay, that means a sub n is equal to 3 over 4n minus 1. So we have 3 over 4 to the 2019 minus 1. Is this divisible by 3? This is 1 mod 3. This is 0 mod 3. So it's not. Okay, so my answer is just the sum of those two things, which is 4 times 2019 plus 2, which is E. 10. The figure below shows 13 circles of radius 1 within a larger circle. All the intersections occur at points of tangency. What is the area of the region shaded in the figure inside larger circle but outside all the circles of radius 1? Okay, we know the inner circles are radius 1. Okay, so here's the center of the whole thing. Here is the radius of the large circle. Here is a maybe helpful diagram. There's 1, there's 2, so this is root 3. And this is also root 3. So the radius of the larger circle is 2 root 3 plus 1. Okay, so now my area is pi times 2 root 3 plus 1 squared minus, how many are there? 13? 13 pi. So this is pi times 4 times 3 is 12 plus 4 root 3 plus 1 minus 13 pi. So these all nicely cancel out. I get 4 pi root 3. 11. For some positive integer k, the repeating base k representation of the base 10 fraction 7 over 51 is this thing. Okay, so I know this is going to be like, if k is 10, it would be 23 over 99. So here it should be 2 times k plus 3 over k squared minus 1 is equal to 7 over 51. let's solve it. So 7k squared minus 7 is equal to 102k plus, 153. Should I just guess and check? Maybe the top is 21, in which case I get 18. K is 9. That's not big enough. Okay, maybe the top is 35, in which case I get 32. K is 16. So in this case, on the top I get 35, and on the bottom I get 255, and dividing by 5 on both sides does simplify that, so 16. 12. Positive real numbers x not equal to 1 and y not equal to 1 satisfy log base 2 of x equals log base y of 16 and xy of 64. What is log base 2 of this fraction squared? Okay, so let me rewrite this as log of x over log of 2. Oh no, I'm going to use base 2 change on the right side. So I get log base 2 of 16 over log base 2 of y. So that means log base 2 of x, log base 2 of y is equal to 4. Okay, on the right side, I'm just going to take log base 2 of both sides. So log base 2 of x plus log base 2 of y is equal to 6. Okay, call this A, call this B. So I know AB is 4, A plus B is equal to 6. And this is asking me what is A minus B squared. It's the same as A plus B squared minus 4AB. So this is 36 minus 16 is 20. 13. How many ways are there to paint each of these integers 2 through 9 red, green, or blue such that each number has a different color from each of its proper divisors? Okay, 3 colors. Okay, proper divisors. That means, let's just start writing out the restrictions. So 4 does not get the same color as 2. Let me write it like this. Okay, 6 does not get the same color as 2 or 3. 8 does not get the same color as 2 or 4. 9 does not get the same color as 3. Okay, so 2, 4, and 8 are all different. So we have 3 factorial ways of choosing 2, 4, and 8. Uh, 5 and 7 are totally independent. So I get 3 choices for each. That's 9. What's left? 3, 6, and 9. And what do I know? Six is the only one that relates to ones we've done so far. So how many choices do I have for 6? It can be anything other than what 2 is. So that's 2 choices. Now 3 can be anything other than what I made 6. So 3, I have 2 choices. And now 9, I just have to make it not the same as 3. So 2 choices. All right, so I get 6 times 9 is 54 times 8, 432. 14. For a certain complex number c, This polynomial has 4 distinct roots. What is C? Okay, let me just work right here. Okay, what's happening here? This is like x minus 1 squared plus 1. So that's got 2 complex roots, and they're distinct. This is x minus 2 squared plus 4. So that also has 2 complex roots, and they're distinct. Okay, so that's already all 4 roots. So this has to have, its roots have to be of this form. Okay, these roots have magnitude equal to 1. These roots have magnitude equal to 2. Square root of the last number. No, that does not make sense. Yeah, okay. No. Okay, well, how do we do this? Well, let's just write the roots. Okay. We have 1 plus or minus I, are the roots of the first thing, and then 2 plus or minus 2i are the roots of the second thing. Okay, I need 2 of these that multiply to 4. Okay, so 1 minus I and 2 plus 2i is 2 times 2, which is 4. Okay, so these are the good roots. And C, I want to take the sum of these 2 roots, so I get 3 plus I is the sum up to sign, and then I want the absolute value of that, so that's square root of 10. 15. Positive real numbers a and b have this property. All 4 terms on the left are positive integers. That's nice. Okay, that means that root a is equal to 10 to the m. So a is 10 to the 2m, b is 10 to the 2n. Now I have square root of log a is 2m plus square root of 2n plus m plus n is equal to 100. Okay, I want a times b, which is going to essentially come down to finding m plus n. Okay, let's call this k and this l. So I have k plus l plus m is equal to k squared over 2. N is l squared over 2, and that's 100. I know k and l are integers. So this means k plus l k squared plus 2k plus l squared plus 2l, just multiplying by 2, is 200. So k plus 1 squared plus l plus 1 squared is equal to 202. I need 2 squares adding up to 202. 4 plus, no, 9 So 193, 16. It's 180. No. Okay, what if it's 169 plus 33? No. What if it's 144? I'd have to add 58? No. What? Okay, and I know k is an integer. All right, let's see if I did this right. Root a has to be 10 to the m. Okay, I think this is right, and this is log a is 2m, square root of that. Okay. Believe this. I just multiplied by 2. I added 2. Okay, I just can't find two numbers that add up to 202. Am I missing something? K and L have to be integers. $196, no. 169. Uh, 33. Okay, 144. 100. No. All right, I'm concerned maybe there's a mistake in how this problem's written. Let me do 16. The numbers 1 through 9 are randomly placed into the 9 squares of a 3 by 3 grid. Each square gets one number, and each of the numbers is used once. What is the probability the sum of the numbers in each row and each column is odd? Okay, so effectively it's like 1 0 1 0 1 0 1 0 1. 4 zeros, 5 ones that we're replacing. And we need three ones in one row and then 2 ones in the other row. So it's got to look something like that. One of the rows like that, and then other row like that. That's what it's got to be. Okay, so how many positionings of the ones work? Well, there's one for each of these, so there's 9 total. How many total possibilities? 9 choose 4. So it should be 9 over 9 times 8 times 7 times 6 over 4 times 3 times 2. No, I don't want to do that. Save the 9 to cancel out with the 9 on the top. This becomes 2, 114. B. Okay, 17. Let S sub k denote the sum of the kth powers of the roots of the polynomial x cubed minus... Okay, this is like Newton's sums. So if I plug in the 3 roots and add the equations I get S sub k plus 3, I'm going to multiply by x to the k first, minus 5s sub k plus 2 plus 8s sub k plus 1. Okay, minus 13s sub k So I get 5 minus 8 plus 13. This should equal 0, which is 18 minus 8 is 10. Okay, 18. A sphere with center O has radius 6. A triangle with these sides is situated in space that each of its sides is tangent to the sphere. So, okay. Picture looks like this. Oh, I see. Okay, so where this circle is not necessarily the great circle of the sphere, but is some circle. All right, so I need to know this radius, which is the in radius, and I know that the area is equal to radius times semi-perimeter. So we need the area of this thing. It's 15. This thing is 24, so it's 12. 9, 12, 15. The area is 9 times 12, which is 108. Is that right? Yeah. Okay, so the semi-perimeter is 15 plus 12, which is 27. So that means that R is equal to 108 over 27. Both are divisible by 9, so it's 12 over 3. Oh, nice. Okay. 4. So now I have this sphere. Okay, I have like a circle like this. It has radius 4. The sphere has radius 6. I want this length. So that should be 2 root 3 squared minus 2 squared, which is 2 root 9 minus 4 is 5. Okay, 19. In ABC, we have these values for the cosines. What is the least possible value for the perimeter of ABC? Ew, okay. So this tells me C is obtuse. Oh, okay, least possible perimeter. The triangle is determined up to scaling, but I just need to know what the scaling is. All right. So let me do the law of cosines on C, because that seems the easiest. C is a squared plus plus 2ab divided by 4. Okay. Okay. I think I want to use these formulas. Area is 1/2 AB sine C. So this means that AB sine C is equal to BC sine A is equal to CA sine B. Oh, maybe this is easier. Sine C over sine C is equal to, use the law of sines. B is sine B, A over sine A. Okay, yeah. So sine A is going to be equal to, sines are all positive. It's going to be root 15 over 4. Sine B is equal to 49, 64, root 15 over 8. Sine A, whoa, okay, this is sine C. Okay, sine A is equal to 256 minus 121. Oh, that's the square I was missing. Okay, I know how to do that earlier one. 135. So this is root 135 over 16, which is 3 root 15 over 16. Okay, let me use this space. Okay, so I'm gonna scale these all together. So I'm gonna multiply by 16. I'm gonna get rid of the 15. A times 16 over 3 root 15 is equal to B times 1 over sine B, 8 over root 15. It's equal to C times 4 over root 15. Okay, I can get rid of all those. I can make this a 4, I can make this a 2, I can get rid of this. So I get 4/3 A is equal to 2B, which is equal to C. I want the smallest integers that satisfy this. So I would take A to be 3, B to be 2, C to be 4. And they're all 4. So I get 9, 20. Real numbers between 0 and 1 inclusive are chosen in the following manner. A fair coin is flipped. If it lands heads, it's flipped again, and the chosen number is 0 if the second flip is heads, and 1 if the second flip is tails. On the other hand, if the first coin flip is tails, the number is chosen uniformly at random from the interval 0, 1. Okay, so we have 1/4 chance of 0, 1/4 chance of 1, and then 1/2 chance of something in between. Two random numbers are chosen independently. What's the probability that x minus y is greater than 1/2? Okay, I would know how to do this except for the 1/4, so let me just take those cases. Say that x is equal to 0, then what's the probability? Then we get a 1/2 chance. If x is 1, we get a 1/2 chance. So now x is not equal to 0 or 1, and now let's say y is equal to 0. We get a 1/2 chance in this case. It's not equal to 0, 1, y is 1, we get a 1/2 chance. And then neither are 0, 1. Then we have this picture. We're choosing like a random point in the square. We want to know what's the probability the difference is greater than 1/2, so we have these regions, okay, which is 1/4 of the square. So, okay, I get, all right, if x is 0 or 1, or if x is not 0 or 1, but y is 0 or 1, in both cases, I get 1/2 probability. In the remaining case, which is 1/4 likely that they're in between, I get 1/4 probability. So I get 3/4 times 1/2 plus 1/4 times 1/4, which is 16, 6 plus 1, 7/16. Okay. Let's do these last ones. 21. Okay, so I'm going to get terms of this thing. There's going to be 144 terms, and they're of several different types. I mean, I guess I can just calculate what I get. 2 of them are 0 mod 8, so I'm going to get 2. 2 of them are 4 mod 8, so those cancel the first 2. Right, so I can get rid of these and get rid of these. 4 of them are 1 mod 8, so I'm going to get 4 times e to the I times pi over 4. That's going to be my first term. Okay, on the other side, I have to kind of invert this whole picture, so these are still 0s, these are still 4s, these are -1s. Now, still the 0s and 4s cancel out, and I get 4 times e to the -I times pi over 4. So I get oh, it goes up to 12. Okay, and I stopped at 7. Okay. So I need to, I get these whole things, and then I get an extra 1, 2, 3, 4. Still 0s and 4s cancel out, and this should just be 6 instead, so 36 is my answer. All right, I'm going back to the one with the squares, 15. Let me knock that out. Okay, somehow I forgot 121 and 81 work. So that means k is 10, this is 9, so L is 8. Okay? That means that this is M, this is N. So this means M is equal to 50. N is L squared over 2, so 64 over 2 is 32. The sum is 82. what do I need? AB. AB is equal to 10 to the 2 times m plus n, so this should be 10 to the 164. Okay. Let me do 23. So I'm just going to do this one more step, and then I'm going to assume the pattern is right. We get 5% or 5 heart 4 diamond a sub 4. This is going to be 5 raised to the 1 over log base 7 of 4 diamond. So I raise it, or in other words, I multiply this by log base 7 of a sub 4, which is 4 to the 1 over log base 7 of 2. So I'm going to get that, this comes out. Okay, I believe it. So a sub n is equal to n to the 1 over log base 7 of 2. So I get, I want log base 7 of 2019 raised to the 1 over log base 7 of 2. Pull this out, so I get log base 7 of 2019 over log base 7 of 2, which is log base 2 of 2019, which is about 11, nearest integer. So D is my answer. All right, let me do 24. For how many integers is this an integer? Okay, and my idea is just look at a prime at a time. So when is 2 going to be bad? Let me just do n equals 4. So for 4, we get n squared minus 1 is 15 factorial. On the bottom, I get 4 factorial to the 4th. Count the 2's. So on the bottom, I have 2 to the 4th times 4 to the 4th. On the top, I have, that's 4, 12 2's. On the top, I have 7. I get 7 plus 3 plus 1 2's. I still don't have enough 2's. It's bad. What if n is 8? I mean, my sense is that prime powers are bad. 63 factorial over 8 factorial to the 4th. So on the top I get 31 plus 15 plus 7 plus 3 plus 1. On the bottom I get 4, oh, this should be to the 8th. 4 plus 2 plus 1 times 8. So this now is 7 times 8 is 56. This is 46, 56, 57. All right, I don't have time, so I'm going to just assume that prime powers are the bad ones. So 1 is fine. The bad ones are going to be 2, 4, 8, 16, 32, 3, 9, 27, 5, 25 is bad. 7, 49 are bad. Okay, 11, 13, 17, 19 are bad. 23 is bad. 29 is bad. 31 is bad. 35, 37 is bad. Okay, 41 is bad. 43 is bad. 47 is bad. How many? 5, 8, 10, 12, 16, 20, 23 are bad. No! Okay, that's too many. Is 16 really bad? Okay. Should be... Okay, let's check n equals 9. 9 squared minus 1 is 80, so I get 8 plus 2 on the top. On the bottom I get 3 plus 1 times 9. Yikes. Sorry, it's wrong. Okay. 26 plus 8 plus 2, which is 36. That's actually fine. Okay, so 9 is not bad, 25 is not bad, 49 is not going to be bad. 8 is bad, but it's just barely bad, so I'm going to assume these are bad. These are fine. Okay, 3, 4, 5, 6, 10, 14, 17. So I think 33 is my answer. Not at all confident about that. All right, let me do 22. Okay. right, so there's going to be a point of tangency somewhere over there. And BP over CP is 3. If I could get anything in that picture, I'd be happy. Okay, so let me just say make a right angle there. So this is 17. This is the height of my equilateral triangle. So I have h over 17 is equal to, let's call this d. dp over, let's call that h, ph. Okay. I have BP over CP is 3. So that looks like BP so these are all congruent. Okay, so that means I roughly know this is like x, this is x root 3, this is also x. So I want to use AP, PO. This is going to be, it's like 2 root 3, and when I do that, oh, 1 minute left. Okay, 4, 3, I get root 7 there. Okay, so this is in the same ratio. This is the long leg. It's like the root one that goes with the root 3. So this is 17 root 7 over root 3. And then I know this whole thing is 20. Okay. Oh, I'm out of time. I'm going to elect not to guess and just leave it at that. So, it's a good run.